Don't have very many. Got to find this here. There we are. So whoever's online, good morning to you. And then good morning to everybody here. All right. So good morning to you guys. Is it kind of nice and cool today at least? Is it cooler or is it just my imagination? I have no idea. Don't even know. Anyway, okay, so what kind of stuff have we been working with? Do you guys remember? We've been working with some special triangles. You guys remember? Yeah, we're going to try to put some of these ideas together. What I tried to do earlier today is get for us. That kind of looks okay. Right? Let's get this out of the way. Anyway, so this is what's called the XY plane. Okay, so you guys know what's a plane anyway, by the way? Do you guys know what a plane is? Right, what's a plane? It's like just like if you look at your paper, that's a plane. In other words, it has only two dimensions. It has a horizontal dimension and a vertical dimension. So it's in two space, right? So we call this the XY plane because you have the x-axis, of course, represents the what? Well, it's horizontal axis, and the vertical axis is the y-axis, and so we refer to this as the what? Just as the XY plane, so you guys know. Okay, now, and then what you guys see is a circle here, okay? You guys okay with that? You guys see a circle? Now, what kind of things do you know about a circle? Let's stop and think about a circle. Okay, what is the information that you guys know about every circle? You guys have any idea? Tell me what you know about circles. Well, what do you mean about a 360 degree? We mentioned somebody mentioned 360. What do we mean by that, right? Do you guys know? So, like if I put a ray here, ooh, look at that, using geometry language, right? This is a ray. It goes in one direction. And then if I rotate the ray, so you're giving me information you guys know about a circle. We're going to rotate the ray counterclockwise, right? And you say, what does that look like? Well, essentially, it's going in this direction. Okay, you guys okay with that, counterclockwise? So the comment that was made is something about 360. What does that even mean? Do you guys know? What does that even mean? Just trying to tap into what you guys know about a ray. Remember, this is a corner here, right? Isn't that 90 degrees? Yes. Well, yes, we're saying, okay, notice this. This is 90. And this measures another what? Since that's another corner, what does that measure? 90. You guys okay with that? And as you keep rotating, you rotate another what? That's another corner, 90. And you rotate again, or you rotate some more. Another corner's what? 90. What does that measure? That's 360 degrees. Aren't you at the same location where you started? In other words, this ray that we talked about, isn't that at the same starting point? Okay, do you guys agree with me on that? So I just want to make sure you guys know one full rotation of that ray, just trying to get all the information you guys know about a circle, still kind of review. This measures what? 360 degrees. Is that true? All right, you guys okay with that? Anybody have any questions? One full rotation? So I'm going to write that down here. Even though I already have that, I'm going to say one rotation. Boy, I don't even have space for that. So let's write down some facts about our circle, okay? One rotation equals what? It's 360 degrees. Okay, you guys agree with that statement? Right? And you go, what do you mean one rotation? Well, if you start there on the positive x-axis, because these are all corners, this is called your really, it's called an initial your initial ray. And if you rotate counterclockwise here, even if you rotate clockwise, one rotation equals 360 degrees, okay? All right, you guys okay with that? So if we start there in that positive x-axis and we rotate, and we always, put that kind of information this way, right? That's counterclockwise. We put that's 360 degrees, right? You guys okay with that? What do you guys think? Is that hard? Does that make some sense? No? Okay, so what else you guys know about circles? Just trying to get some of tap into what you know. Anybody? What do you guys know about circles as I start to get my coffee in me? What do you guys know? Anybody else? What do you guys know about circles? Anything that you know about circles. Do you guys know about circles? Maybe you don't know about circles. No? Any information you guys have, we got to put it all together. Because you're right about that. What's that? Okay. What's the area of a circle? Pi r squared. What is r? R is a radius. So you go, Mr. Judge, a circle has a radius? Yes. Anybody know what a radius is for a circle? It's half the diameter. Okay, but, what does that even mean? The distance from the what? Well, from the center of the circle, if it's coordinates, this is 0, 0. Is that right? So the distance from the center of the circle to the what? To the edge of your circle has a radius or has a numerical value. That distance. Notice that's diagonal distance. You guys know what I'm saying? It's like a form of diagonal distance. You guys see where we're going with this? So every circle has a center. Sometimes they put C for center. Because this is coordinates, it's a plane, we have an address, 0, 0. So every circle has a radius. That's the distance from the center to the what? To the edge of the circle. So thank you. Thank you for that information. And yes, it's twice the diameter. You go, what's a diameter? Well, the distance all the way across through the center. So those are some things that we know about a circle. That's good. Anything else that we know about a circle? Area is pi r squared. Hey, what's the circumference of the circle? What's that formula? If I ask you first, what's the meaning of circumference? Do you guys know what a circumference is? That's just the distance around a circle, right? So if I said to you, guess what? If you can walk around that circle, that perimeter of the circle, that's called the circumference. What's the formula for the circumference of the circle? This is important too. Yeah, the circumference is 2 pi r. Now, they don't say perimeter, and the reason they don't say perimeter, because I guess a circle's what? A circle's very special. It's a special shape, okay? So, from geometry, you got this concept of a perimeter, the distance around the object, right? But when it comes to a circle, they call that a circumference. It's very special. Okay, you guys okay with that? Anything else? What else you guys know about? This is some good information, is that right? You guys know anything else about a circle? And just want you guys to note here, since we talked about radius here, we have something called a unit circle. Do you guys happen to know what a unit circle might mean? do you guys think? Uh, what does the word unit mean? Does anybody know what a word? The word unit has multiple meanings, but when they say unit circle, what does that mean? What do you guys think that means? What's a unit circle? Anybody have an idea? Anybody here like baseball? Nobody? No? What do they call you guys at your age? Are you millennials or are you Gen Z? What does that even mean? That's what I'm saying. Gen Z probably doesn't like baseball. Well, there used to be a baseball player by the name, his nickname was the Big Unit. And when I think of that, I think of the stuff like the big unit. You have a unit circle. I think of the word unit. Why do they call him the Big Unit? Who's the Big Unit anyway? The Big Unit is Randy Johnson. You go, I don't know who Randy Johnson is. Right? Ask your dad, ask your grandfather, your uncle, your aunt, your godmother. Who's Randy Johnson, the Big Unit, right? He's a tall guy, and he looks like the number one. Tall, one. You guys get it? You know what I mean? Unit, big unit. Well, you got something called the unit circle. So whenever I see, that word unit circle, I remember it means the number one. What do you think a unit circle is? It's a circle with what? It's a circle with radius 1. Do you know who Randy Johnson is? Okay, thought so. Gen what again? Gen Z, I guess. Okay. Circle radius 1. So if this radius were to measure what? 1, we would call it a what? A unit circle. You guys okay with that? So whenever your radius is 1, we call that a unit circle. It's known as the unit circle. No big deal. Anybody know the equation of that unit circle? Good. That's what I'm looking for. X squared plus y squared equals 1. This is all part of the what? This idea of a unit circle. Okay. But looking at our notes, in general, okay, generally speaking, the equation of a circle is x squared plus y squared equals r squared, okay? And this is centered at the origin, by the way, so we have to give that information with radius r. And again, r is always positive, okay, for a circle. But, we have these general ideas and general notes for a circle. Pretty good stuff. So we're getting some good information about a circle, about a unit circle, and everything we know about circles here. Okay? You guys okay with that? Pretty simple? Okay, and what do you see this dot I just drew? This dot here is what we call it. This is a point on the circle, XY. Because if you said, hey, Mr. Judge, you gave me an equation for a circle with the letter X and the letter Y, and I'll say, yeah, every pair of numbers that satisfies this relationship of x squared plus y squared is that value r squared, is a point that's on the circle. So it's a point on the circle, to let you guys know. And that should make some sense. So if you guys plotted points in your life, you guys know, okay, there's points in the XY plane, isn't there? No big deal. The ones that satisfy the equation of the circle are all on that plane. On the circle. Okay, good. And this also brings me up to some other ideas here. Just kind of brainstorming about everything we know about circles because it's coming up. Trigonometry, in some ways, it's like the study of triangles and circles. Two shapes. Kind of interesting in my mind. Study of triangles and circles. So there's something a little bit more technical coming up I want to point out to you guys. You see this axis and X and Y axis stuff? Do you guys know? I'm going to change the color on you. We call these quadrants. Do you guys know that? Like Q for quadrant, this is called quadrant 1. This upper right corner, quadrant 1. What's so interesting about quadrant 1? Anybody know? What's special about quadrant 1? There's something special about it. What's so special? What do you mean? Only positive numbers. What's positive in quadrant 1? Well, every point, I'll put this point right here in purple, right? Every point in quadrant 1 has a special attribute. And you're right. What do you mean by that? You're right. It means that the x coordinate is positive and the y coordinate is what? Positive. This is an attribute of quadrant 1. Of quadrant 1 points. That's going to be an important detail for us. So everything that you see in quadrant 1, that upper right corner, the x coordinate is positive, y coordinate is positive. Anybody know why? Why are they both positive? Right? If I said to you, know this address out here, isn't that on the positive x-axis? And then the y-coordinate value, isn't that the positive y-axis? Okay, you guys see what I'm saying? So going to the right and going up, those are two positive values when you plot points, if you guys forgot about that, right? So I'm going to say to you guys, what do we call this quadrant, if you guys remember? What's the name of that quadrant? Quadrant what? Isn't that quadrant 2? Now, what do we know about the coordinates in quadrant 2? I'm going to put a dot there. What do we know about those quadrants? Or those quadrants, or that quadrant? What's special about that? X. So if you go out here, maybe we should move the point. If you try to plot that point, the x coordinate now is way over here, but that's what? Negative. Good. And notice what about the y coordinate value? It's still positive. That's what I want you guys to remember here. Okay? So that's what's special about quadrant what? 2 in terms of any points in that quadrant. Okay? Does that kind of did you guys know this already? Does that ring a bell? Right? Okay, what about quadrant what? 3. You got to point out here. Let's get a point out here, right? And we're going to call this quadrant 3. This is what it is. It's kind of going by counterclockwise orientation, by the way, right? Counterclockwise orientation. This is quadrant 3, and this would be quadrant what? 4. So let's ask you, what do you guys know? If you were to plot that point, you go to the left for x, so x is what? Good. And now for the y-coordinate, what do you guys know about the y-coordinate? Yes, the y-coordinate is also negative when you plot points. So I want you guys to be aware of this information because this is going to be helpful for us. Okay? All right, you guys okay with that? Some very good pieces of information. Now, if you were to plot a point in quadrant number 4 now, what do you guys know about your points out here in this unit circle? Well, let's see. It's going to be to the right. So, yes, x is what? Positive. Is that right? But it's down. So, what does that mean? Y is negative. Yes. So, you need to know this stuff. This is some information we need to know physically about the, really about the circle and about the plane there. And we're going to work with this kind of picture for the whole semester practically, So just to let you guys know, we're starting to put some pieces together here, right? And so if you said, oh my God, Mr. Judge, your class is so boring, I know all this stuff. Well, we're going to start putting some pieces together here, okay? Now, there's other special points, though. Let me get out the red. You see this and you see this. What do we call those points from algebra? Anybody know? What are those points called from algebra? What's that? The red ones I just threw down there. They actually have names. What are those names of those points? Let's see if you guys remember. They have names and they have addresses. What are the names of those points? Anybody remember those names? What are these called? Do you guys know? Well, where do they lie on? They're on the x-axis. Yes, they're called x-intercepts. Okay, they're on the x-axis. It's where the circle intercepts the x-axis. Those are x-intercepts. You guys okay with that? All right. So what do you guys know about the address of the x-intercepts here? This is like x0, and this is going to be also what? X comma 0. That's the address. Oh, I'm sorry. It is the address, but if we know the radius, I'm going to say this. It is the definition, but it's R0 in particular, and here it's minus R0. You guys okay with that? And you say, why? Because you knew the what? The radius. So that's also an important detail, okay? All right, I'm glad I drew this morning, this circle here. And then you say, okay, but there's these other what? You have these other, points where the circle intercepts not just the x-axis, but the y-axis. What were those called? Y-intercepts. Good. Those are y-intercepts. Outstanding. What's the address here, though, since you know the radius being r? 0r above here, and this is 0 negative r. Okay? So, ladies and gentlemen, believe it or not, there's a lot of information here that is very, very useful for us. Okay? So this is kind of a lot of the stuff that we know about what? Circles. Does anybody know anything else about the circles since I'm on the topic? Trying to get this coffee in me and trying to wake up. Anybody know anything else about this? What do you guys think? Anything? Trying to think, is there anything else we know about a circle? Because I'm going to erase all this stuff. I think we're good. What do you guys think? Is that amazing? Okay. So I wonder what will happen if I do this. Yeah, it didn't bring everything. Anyway, it's okay. I'm gonna do this here. Let's see if this. So I'm going to give you guys a unit circle here, okay? But I'm going to do something here. I don't know. I'm going to put an angle there, theta. What was theta called in geometry? Theta is called, you guys remember what they call theta? A central angle. Okay? Theta is a central angle. Now you might say, why do you think they call it a central angle? Well, it's the angle in the center of a circle in this way. So they call that a central angle. And you could rotate theta counterclockwise, which means theta is strictly positive, okay? And again, you might say, what do we think? What do you mean you're rotating? Well, remember, we start with this ray out here on the positive x-axis. And then they rotated this ray counterclockwise an angle called theta. There we go. And you get now a central angle. Is that true? So I'm going to do something here. And I don't know what color. Let's use blue. I'm going to draw a line straight down here. Okay, and I'm going to create now what? This is known now as a right triangle. Are you with me on this? My radius is 1, so this here is going to be a unit circle. Yes, I know the equations x squared plus y squared is 1, centered at the origin from algebra. But, you know, we're going to start to get used to this picture here. Now, do you guys happen to know, what is this called here? If I get out red here. I'm going to give that a letter I call S. Your book doesn't call that S, it calls it T, but it doesn't matter. Do you guys know what S actually is called? As I transition from this circle, what is it? What is S known as? Well, good. We say S is an arc what? Arc length. Why do they use the word arc? Anybody know why they use that word arc? Because what are you supposed to be looking at here? What is that? That's an arc. Is that true? You guys know what I'm talking about? This is called an arc. It's not a line, is it? It's not a line. It's an arc, but it measures what we call arc. It has a length. So believe it or not, if you walk along that arc, you're walking a distance. Is that true? So always remember that. Generally speaking, in algebra and mathematics, S represents arc length. And this is going to be for us, let's write that down here in our notes too. Distance along the, well, it's distance along the circle, but in this context, it's distance along the what? Unit circle. You with me on that? So we're starting to do two things here. We're starting to move away from geometry, although we do have to remember geometry. Because there's a relationship here, okay? Every central angle has an associated arc length. Write that as a fact here. Here's our fact. Every central angle has an associated central angle theta has an associated arc length called S. Every central angle. So if you say, I don't believe you. So for example, ladies and gentlemen, you go, okay, what do you mean for an example? Remember, if theta is 45 degrees, they're going to ask us, what is S? What is S? So if theta is 45, we need to find the arc length. Does anybody know how? Because like if I said to you, all they're saying is that central angle is 45 degrees. What's the distance here now if we change this to 45? And easier said than done. That's 45 degrees. What is S associated? What's that arc length? Let me give you guys a clue here. Well, you see this line here? Let me go back. I'll put this in purple. See that line? If you rotated that ray in this way, what's that rotation? You want to know two things. What's the rotation? How many degrees was that rotation? 180 degrees. Is that right? Okay. Okay. 180 degrees. What would that what is this distance? If this is a unit circle. Think of the circumference. Yes. Huh? Well, let's think about this. What's that? Remember what was the circumference of a circle? 2 pi r. And if your radius is what? 1. The full distance is 2 pi times 1. But you didn't go a full distance now, did you? You guys see what I'm saying? I'm doing the scratch work here. So let me go up here. Even though there's no space, I'm doing scratch work here. So what I'm saying in red, that's not a full circle in terms of distance. Radius is 1. That's a half a circle. So what I would say to you, that distance is what? What's half of 2 pi? That distance is pi because the radius is what value? 1. Okay, you guys okay with that? So you go, oh, the full distance in blue, the full distance would be 2 pi times 1, which is 2 pi, but we're not referencing that. I mean, we could. We could use that, but I'm just going to give you this idea here, okay? Here's what you guys want to know. You want to know this, that pi is the same as 180 degrees. It's actually a ratio here. And we call that pi, this is known as pi, this is radian measure. Okay, pi, by the way, is a real number. Is that true? So in other words, you guys want to know what this means. Pi is the same as 180 degrees. Radian measure simply means a real number value. So this is kind of like a starting point. We could have said, and maybe it would have been easier to say, hey, Mr. Judge, can you say 2 pi is actually associated with that 360 degrees? Okay, you guys know what I'm saying? Maybe that's easier. Maybe you say, Mr. Judge, in blue, this is a unit circle. I would have rather you tell me that the distance around here in blue is 2 pi. And yes, that's associated with 360 degrees. We've seen that earlier. Now, notice this. If I said that to you, divide by 2, doesn't that say pi is what? 180 degrees associated with that? It's not even approximate. It's exact. So, in other words, this here, what I just gave you, is the standard conversion of working with what we call radians and working with degrees, ladies and gentlemen. The standard, you look in any trig book, what are they going to say? Pi radians is 180 degrees. Every trig book in the world, pi radians is 180 degrees. That's where they got it from. You could say 2 pi is 360, which means pi is 180. Okay, you guys okay with that? For a unit what? Circle. Randy Johnson. So, ladies and gentlemen, this is an important detail to use. Okay? You guys okay with that? Now, you might say to me, how do we use these here? How can we use this relationship? Well, it's very simple. Okay? If you know pi is 180 degrees, what that does for you is it gives you two special unit ratios. Unit ratios? Yes, unit ratios. What's a unit again? What's the meaning of a unit? 1. Let me show you guys. You guys remember some algebra? What if I did this? I'm going to divide both sides by pi. Remember, for every equation, I'm free to divide any side by the same, any non-zero number. Pi is 3.14. So what do you guys get on the left? This is saying 1 is the same as what? 180 degrees over pi. Now, we typically write it this way. 180 degrees over pi is the same as the number 1. This is why they call it a unit ratio. Very, very special relationship here. It just comes from algebra, ladies and gentlemen. Okay, you guys okay with that? Wrong button. So this is, I'm going to erase this. I'm going to emphasize this. I'm going to say this is known as this is a unit what? Unit ratio. Unit ratios are everywhere in science. I mean, if you want to be good in science, ladies and gentlemen, you know what the secret is? It's a lot of ratios. Unit conversion. This is going to be unit conversion. This is where it comes from. So don't tell anybody. If you really want to be good in science, there's a lot of ratios, unit conversion. This is where it comes from. What if I decided I'm going to divide both sides by 180 degrees? What do you guys get now? You get now what? Pi over 100 and what? 80 degrees is 1. This is canceled. This is another what? Special unit ratio. Okay, now they're different ratios. What's a ratio, by the way? What do we call a ratio? A ratio is a what? Fraction. Okay, you guys okay with that? So it's a special fraction. These are special fractions. All right, you guys okay with that? Now you might say, well, this doesn't tell me anything. We're trying to convert this, right? Well, what is the angle that they're giving you? Let me go through the conversion process. Here's your conversion. Tell me if this is valid logically. Is 45 degrees equal to 45 degrees? Is that the same? You guys okay with that? Here's the logic behind unit conversion. What if I said, I'm going to take 45 degrees, I'm going to multiply it by 1. Is that still equal? Why? Because 1 times anything is itself. See this? What do we call this here? We call this Randy what? Johnson. This is called the what? This is the unit. This is why they call it a what? Unit conversion. 1. So what I'm going to have to now do, ladies and gentlemen, is I'm going to have to use the right unit. Which is the right unit? The first one or the second one? What do you guys think the right one is? Which is the one I use? There's a very simple reason why. We're going to use this. We have to use the second one. We do? Yes. And there's a reason why. Pi over what? 180 degrees. Why do we use this? Why not the other one? It's a unit, 180 degrees over pi. Does anybody know why? Okay, why do we have to use this one? It's a very good reason. Focus on this. What is this, ladies and gentlemen? See that symbol? What's that a symbol? What's that a symbol of? I can use the word degree. Pi. And yes, that's really in what again? Radians. That just means real number. It's kind of redundant in some ways. Over 180 what? Degrees. So what I'm saying to you is that symbol of degrees, I just put in words, needs to be on top and bottom. Why? Well, be careful. What's the word? Yes, you're right. But what am I looking for? What word? Why do you have to have degrees on top and bottom? Why? So you can what? They can cancel. You see, ladies and gentlemen, units cancel each other if they're on top and bottom, just like numbers. You might say, what are you talking about? If I said to you, you know what 6 over 9 is? Factor 6, this is 2 times 3 over 3 times 3. You guys with me on that? What am I talking about? 3 and 3 what? Cancel. Numbers cancel if they're on top and bottom and they're the same. So that 6 over 9 becomes what? 2/3. Well, all I'm saying is that the degrees cancel too. So if you have any units that are the same on top and bottom, what happens? They cancel. That's a big deal. So in other words, and you want to get used to that because you're going to see more of that. And this is actually, what happens is people who get good at science know this stuff. They go, yeah, cancel your degrees and degrees. And what are you left with? 45 times pi over what? 180. Now be careful. You say, what do I have to be careful? What you now need to focus on doing is simplifying the what? The numbers. Okay? Do you guys happen to know that 45 goes into 180 4 times? Do you guys know what I'm talking about? Maybe you say, I don't know how to simplify. Okay, 45 is what? 9 times 5. Here's what I'm saying. 3 times 3 times 5, right? Break it down into your primes. 180. Okay, what's 180? Well, that one's even hard. 90 times 2. Oh, 45 times 2. So in other words, let me do this here. I mean, you could break it down that way. But what do we know? 45. And this is 45 times 4. Is that right? So you have cancellation. So ladies and gentlemen, let's see what we just did. You simplify the fraction. You simplify that fraction, that number, reduce the lowest terms. So if you look on top, what does that mean? Okay? It means the following, that 45 degrees is equal to what? Pi over 4. This is your conclusion. You have converted your degrees to what? Radians. In other words, this is measuring what? Pi over what? 4. Let's get rid of all the other stuff. And that's kind of what you guys have to do in a trig environment. Okay? Convert what? Degrees to radians. Convert that central angle to the arc length measure associated with it. So 45 degrees is associated with pi over 4, what? Radian measure. Real number, really. Isn't that wild? And this is along the unit circle. It has to be that unit circle. It has to have this number 1. All based on Randy Johnson. Unit circle. The big unit. Okay, so this is a conversion process. You know what they call this? What did you just convert? This is how you convert what? Degrees to what? Radians. Okay, and just looking for a few things here. What if I asked you guys this question here? Right? What if the central angle was 30 degrees? Remember yesterday we did what kind of work did we do yesterday? What did we do? We looked at two special triangles. What were they? 45, 45, 90 degree? What's the other one? 30, 60, 90. So you know what we're going to do? We're going to convert both of these. 30 degrees and 60 degrees. So let's try that out. We start with 30 degrees, okay? You can say, Mr. Judge, can I do 30 degrees equals 30 degrees? And I say yes. You know what you can use now? Go straight to the special unit. If you're going to convert degrees to radians, what do you use? You have to use which one? What do you guys use? The second one. Pi over what? 180 degrees. You with me on this? Why, ladies and gentlemen? So you can cancel out the degrees, cancel out the units. I can cancel it this way. Now, I wrote every gory detail here because the devil's in the details, and sometimes people want to see that stuff, right? And you probably should see it. But this now becomes what? 30 times pi over what? 180. The degrees are gone, ladies and gentlemen. The units are gone. Do you guys know something about 30 over 180? How many times does 30 go into 180? 6 times. So what's your final answer? Pi over 6. So ladies and gentlemen, here's what we did. 30 degrees is the same as what? Pi over 6. Or I should say, the central angle of 30 degrees is associated with pi over 6 radians. You converted. So if you said to me, what does that mean? Well, that means this. If this measured, got rid of some of that, the central angle here was 30 degrees. The arc length is really now what? Pi over 6. That's what that means. Change the central angle, change the arc length. Okay, you guys ever seen this before? Where was it in? Is that in trigonometry? No? Anybody here take trig before? Maybe? Okay. What about 60 degrees? What does 60 degrees become? Right? What's the special ratio? And now look what I'm going to do. I'm going to go straight to the what? Conversion. You could do that. You don't have to say 60 is the same as 60. I do it initially to show people what this is. Now, what can cancel, or what cancels? Your degrees, because it's on top and what? Bottom. So this is 60 pi over what? 180. What do you guys notice about 60 over 180? Do you guys know 180 there? 60 goes in 180 3 times. So what do you have now? It's pi over what? 3. 60 degrees is pi over 3 radians. There you go. What do you think? Okay, conversion. Is that right? And here's what I was going to say to you guys. What if they say to you, hey, what about converting radians to degrees? Can you go the other way? Yes. So, for example, pi over 2. This is what's called radian measure, just real number. Pi over 2. So I'm going to ask you, what is the central what? Angle when it's pi over 2 radians. Anybody remember what you guys do here? You can say, Mr. Judge, can I start with pi over 2 is the same as pi over 2? I'll say yes. Can you say pi over 2 now times 1, the unit? Yes. Can we say pi over 2 times which one do I use now? Remember, we have 2. What do you guys think? Why the first one? Remember, what this is down here supposed to be what? Radian. This is what? Radian, which means real number. So if you use the first one, which is 180 degrees over radian, which is a unit, this is 180 degrees over pi. This is radian, and this is also what? Radian. What do you guys notice? The units what? Cancel. Is that right? The same idea. Radians cancel. And you're just now left with what? Degrees. Pi times 180 degrees over what? 2. But you're not done. Why aren't you done? Yes, you got rid of the radian measure, but what's 180 divided by 2? Oh, I'm sorry. We don't have pi. Pi is what? Gone. What's 180 divided by 2? 90 degrees. So let's actually take a look at what this means here, right? Pi over 2 is the same as what? 90 degrees. So you can write it down that way. You can say pi over 2 equals what? 90 degrees. This is conversion from radians now to what? To degrees. Now, let's think about this. This is powerful. Pi over 2 is 90 degrees. Go back to this circle. You want to know what that means? Here's where you start. Is that right? What's a 90-degree angle? Ooh, sorry. What does a 90-degree angle look like? Isn't this what? Isn't that 90 degrees, ladies and gentlemen? Is that true? So you know what the arc length is along this circle for 90 degrees? It's pi over what? 2. That's what that means. This is still a unit circle, but, this applies to that unit circle. But that's what you're talking about. You're talking about the distance from that initial point, this initial ray. By the way, your book calls that initial point, starting point. Your book's going to call that a terminal point. Okay, whatever. But nevertheless, that distance is pi over 2. This is a unit circle. And that should make a lot of sense. Why? Isn't that another pi over 2? Isn't this another pi over 2? Another pi over 2? So it's 4 times pi over 2. Isn't that 2 pi? Isn't that the distance along a circle, the circumference with radius being 1? It's 2 pi. So it makes a lot of sense. So, ladies and gentlemen, we are concerned with the central angle and the radian measure, because we're transitioning, because we have to be able to do both. We have to know, okay, if that's the central angle, then what is the radian measure? It's pi over 2. Because, ladies and gentlemen, we don't just walk along straight lines. We walk along circles too. Okay, you guys see what I'm saying? If we expand the reality of the world, like when we expanded to diagonal distance, you need the Pythagorean theorem, right? And a lot of people in the world, this kind of breaks my heart. It's a heartbreaking thing. A lot of people in the world, they look at math and they go, oh, it's math. It's useless. I'm going to tell you guys something deep. I think I'm useless without math, personally. I'm pretty useless without it. That's my feeling. I can see the uselessness of a lot of this. So diagonal distance expanded our horizons. We can find out what that is. And, we can start walking along a circle now and know that that distance is pi over 2. And circles are everywhere, by the way. All right, you guys see what I'm saying? It's knowledge here. So that's the important thing. And this is heavy to me. This is 90 degrees, and this arc length is pi over 2. My gosh. Should we have you guys try one on your own? I'm going to have you guys do a few on your own here. I'm going to say convert. Number 1, 270 degrees to radians. Number 2, 270 degrees to radians. How about if we say 2 pi over 3, 2 degrees. Okay, what's our time like? I'm going to give you guys how many minutes? Let's give you guys some time. See what you guys get. Okay, you guys ready? You guys ready for this? All right. Number one, you take 270 degrees, and what do you use here? You know how I think of this? If degrees are on top, what do I need on the bottom? So I put 180 degrees with pi. Remember, that's called radians. It's actually just a real number. And guess what cancels? Your degrees cancel. Is that right? So you get 270 pi radians over 180. Now, how do you simplify 270 over 180? You guys know I can get rid of the zero. Or you can say, is that 27 pi over what? 18. Is that right? And then how do I reduce this fraction? 9 goes into 27 how many times? 3. 9 goes into 18 how many times? 2. Guess what, ladies and gentlemen? It's 3 pi over 2. So you can say, is that 270 degrees, 3 pi over 2 radians? And I'll say yes. That's certainly what it is. So if you went over here and you go, wait a minute, 270 degrees, right? That looks like this, doesn't it? What do I mean? This is 90. This is another 90. What's this? 90, 90, and 90 is what? Is then that 270? So what is this distance now going to be, they said? 3 pi over 2 along that circle. 3 pi over 2. So pi over 2 plus pi over 2 plus pi over 2 is 3 pi over 2. Is that right? Does that make some sense? Pretty good, ladies and gentlemen. What do you guys think? We can find distance along a circle. It's not even a full circle. What was the other conversion? 2 pi radians now. And, I'm going to put the word radian to start. Okay. And what do we need to do? What ratio should we use? 180 degrees over the pi what? So what happens with radians? They go and pi is on top and bottom. And you're left with 2 times what? 180 over 3. Or 2 times 60. Which 2 times 60? It's 100. Is that 120? Double check my arithmetic, ladies and gentlemen. My coffee hasn't kicked in. 2 pi over 3 radians is the same as a 120 what? Degrees. Okay, you guys okay with that? We have some conversion here. What do you guys think? Not too bad? Conversion? So where would actually 120 degrees be? We go back to our circle here, right? Do you guys know where 120 degrees would be? Right? Why would it be something like this? And I got to get rid of... I don't want to get rid of that. I'm going to get rid of that corner. What? If this is 90 degrees here, right? Don't I need an additional what? 30 degrees? You guys with me on this? So what would that be now? 90 plus 30 is what? You guys see my point? This whole thing now measures what? 90 and 30 is 120 degrees. And this distance here, what do we find that it was? Anybody remember what did that measure? Well, it's 120 degrees, but what's the arc length? 2 pi, I think we're using red. 2 pi over 3 what? Arc length. Okay, you guys okay with that? What do you think? Is that pretty simple? It's a conversion process. I want you guys to just note for now, we haven't talked about negative angles, but you can have negative angles. I'll just give it to you guys as a note. You say, why is that a note? Well, we're going to note that for now. We're going to go through more detail later, but if you have a negative angle, what does that mean? You simply rotated what? Clockwise. And so you can have a negative arc length, but that's not negative distance. That just means you're going in the clockwise direction. So if you change your direction, you know, it's just going clockwise. What's clockwise? Right? If you start going what? Like this would be, well, I wanted to use a highlighter. This would be like maybe you can go now this way instead, and you can say that's negative 60 degrees. So if you go negative 60 degrees, the arc length would also be negative, but it just means you went in the clockwise direction. So, you know, that's the idea. Positive central angle, counterclockwise. Clockwise is a negative value. We'll see more of that in the future. The reason I'm saying this to you guys is because when you guys are working on this, I was working on your homework, updating that. And what I want you guys to start doing here is to read section 5.1 from the book. That's kind of really what we're starting to talk about. But conversion is actually in 6.2. It's kind of an odd thing. This book is odd. Is it 6.2 or 6.1? No, 6.1. Coffee hasn't kicked in. You know, 5 and 6 are kind of really, they separated it, but it's really together in some ways. So the author gave an extra chapter, which is kind of weird. So for me, 5 and 6 are somewhat parallel, you know, to some degree. You need to know about these ideas if you're going to start working in chapter 5. It's kind of weird. You know, you need to know about conversion and what this means. All right, what do you guys think? Did you guys learn anything today, or is it still review? It's still review? No? Is it still review, or did you learn something, you think? All right, well, okay, you guys. We'll see you guys later. Take care and stay safe. The last note? Sure. All right, take care.